Hello, everyone. A very warm welcome to this month's Serverless Saturdays. I know we have not been there last month, but we were a little busy, so we could not host all of you. But we are back this month again. And yeah, Dharmendra will not be joining us today for some personal reasons, but I will be your host. So welcome everybody once again, and thank you for joining us today on a Saturday, where you are looking forward to some insightful sessions, and we are here with two really insightful sessions, both with a touch of AI, because we cannot have anything without AI now, right? So yeah, before I get started, I thought I would share a couple of things. One is about the AWS Community Day Bengaluru that I'm also a part of the organizing team that we are planning to do the next month, which is less than 1 month from now. And I thought I'll quickly share some details. So if anybody is interested, they can join us, and we have an exclusive discount code for our user group audience. So yeah, so let me just quickly share my screen. Yeah. Oops. 1 second. Oh, I'm sorry for that. There seems some technical issue. Just give me 1 second. Okay. I hope my screen is visible. Yeah, so we have the AWS Community Day Bengaluru that we are hosting on 11th of July, almost a month away from now. And if anybody who's interested, you surely have to take a look at it. It's our yearly community day that we host as a part of User Group Bengaluru. And I'm just sharing the link in the chat. If anybody is interested, please do take a look at it. We have some really exciting sessions that we have lined up, and a few more to be announced. Of course, a good number of AI-related sessions are scheduled for the event. And the important thing that we are trying this time, apart from the sessions, is we have a bunch of sideline activities, is what we kind of are calling it. Let me just go to there. Of course, only one is kind of announced right now. We are doing something called as Architecture Clinic. So essentially, it's not about you simply listening to the sessions. Rather, you can actually be a part of it, take a part of it, and come up with your own architecture, discuss with the other audience and the participants, and we will have experts on the ground to help you improve, enhance your architecture, whatever you have in mind that you're working on as a side project, or you need some guidance on your work front. We are planning for such things. We will have experts that can help you improve your architecture. Along with this, we have a few more things that we have lined up. Of course, not yet announced on the website, but I can surely share. We have something called as an open mic. So I mean, as you all might know, you will have to submit a CFP, and it goes through a review. And then once selected, your session, you will be able to present. But we have seen that a lot of our audience are interested in presenting, but they may not have gotten a chance to submit the CFP, or for some reasons their CFP did not get selected. For such cases, we have something called as an open mic, where it is an ad hoc. You have something in your mind, you want to come and share with the audience in a dedicated space. You can certainly do that. So we have that, and of course the workshops. are not yet announced, but we have close to 4 workshops that we are planning right now. One of them being very interesting, which of course I cannot share at this moment. But then, yeah, so please do take a look at the website that I've shared the link in the chat. And if you are interested, we have an exclusive 40%, sorry, 25% discount code for our audience. And you can use the code that I am sharing in the chat right now. So yeah, that's pretty much it. What I wanted to share, and for some reason, I think my camera is not loading up. But anyways, um, so yeah, without further ado, let me welcome our first speaker for the day, Sourabh, who is a lead application developer at Schneider. I hope I pronounced it right. So yes, so he will be walking us through how he built from log hunting to AI-powered insights, building event-driven observability on AWS Serverless. Hey Saurabh, glad to have you today, and over to you. The stage is yours.
Hi, hi everyone. Thank you for joining on this Saturday morning. So being Saturday, we are joined here, so it's great. Am I audible? Then I can start sharing.
Yes, Saurabh, you are audible. You can get started.
To share screen. Second. Uh, do let me know if you can see my screen.
Yes, Saurabh, we are able to see your screen. Yes.
Okay. Okay. Hi. So good morning, everyone. I'm Saurabh. I am working in Schneider Electric as a lead application developer, and my day-to-day work mostly focused on the infra and AWS sort of things, where I mostly contribute on the backend stuff and on the infrastructure. That's my day routine, and on the free time I have a keen sites on AWS, so I do write post technical stuff, try to upskill myself, and those are things that I do. I consider myself as a cloud passionate, so I try to be understanding like what are things are happening in the which space and what are the new things that are coming. So that is my day-to-day work that I do. And today in this session, I will be walking you through some of the basic principle that any application developer should follow, where we can indicate observability in our application. So it's from log hunting to AI-powered insights. So as everyone know nowadays, with so much investment that has happened in the AI world, the production system are becoming very complex. People are shipping more, we are pushing more code to production, those things are happening. And because of that, they are there is a problem where people are getting to a habit of getting to debugging ground. So something breaks into production, we have to go into a war room, we have to understand what has break, and then we play a detective role to understand what is happening. Because in production it's not a question of why it breaks, it's more when it breaks what should be done. So that is where observability comes into the picture. And with this session, what I want to emphasize is observability is not an afterthought, it should be done during as part of SSDC life cycle. So when you are developing something, it should be part of your development life cycle, and it is very important. And this is where will try to go and walk through of a simple POC, where we will mimic a standard backend applications, and we'll see how having observability with built-in tool that AWS provides, it scales to the need, and we're able to do an RCA with AI insights out of the box. So that is what we'll do. Okay. So the problem that we are trying to solve is, as I mentioned, in any of the production system that we have in today, we do have some sort of a logs, we do have some sort of observability built in, but let's be frank, having just logs in our system to build up something that does not always helps you. We have to have a proper structure to it, and each of the our application should be linked to when something that is observable. We should have some alarms that is triggered to the application that could say, hey, something has broken, and that alarm should trigger some workflow. So right now, with all the changes that are happening in today's world, we have system that is becoming complex, and with this complexity that we are not adding the complete observability. So we have in bits and pieces, each system is observable, but if we follow some standard guideline and standard practice, we could make the system end-to-end observable, and we don't require to pay a lot of things to external tools. We could build the things with whatever tool the AWS already provides, basically with CloudWatch Insights, alarms, and step functions. We could build end-to-end product that will serve as your base work, as a framework that could scale to different applications. So if you see the left hand side of the slide, this is the problem that we face today. If something breaks, we have something that says something is breaking. Then the production systems, the people that are semi on this production system, the developers and the DevOps team, they join and try to understand why it is breaking. We open the AWS CloudWatch logs or any Kibana dashboard that we have. We try to manually investigate what is the root cause of that error, and then we try to stitch everything, and then we try to give an RCA if the system was failing in production, why it is failing. That on a good day takes around it can easily take around 40 to 50 minutes if we know what actually we are searching for. But if the job is like a needle in a haystack, it will take a lot of time to understand why something is breaking in production. That is where, if we have a proper observability framework built in to the system with the tools that AWS already provides, the work will be which be very much easier. So what we're trying to build is a complete observability framework system that will tell you if something breaks, that will trigger an alarms, and the alarms will be classified based upon different parameter, and that would be dependent upon your business use case. We have a validation error, payment error, or DB error, and based upon that alarms and the objective framework that we have built, we'll have a automatic investigation setup, for which I have used step functions, because step functions, to me, the serverless orchestrator part that step function provide is very easy to stitch different decoupled components together, and it's get the jobs done pretty neatly. And for the AI part, this is the basic part that we have added. So once we are getting any error, we could use the bedrock of provided by AWS to do the AI analysis. So a step function has got a native integration with AWS Bedrock. That is what I'm using in this demo. Based upon the different stages it happens, in one of the stage in the AI workflow stage, it tries to invoke the bedrocks, and we get the analysis from the AI agents. And once all this setup is done, we'll have a RC in our email stating, hey, this has broken, and this were the things that we got, the reason why it was breaking, and based upon that, the RC that was fired. So this is the problem that we're trying to solve. I will go to the next slide, and then we'll see how to build this up. So as I mentioned before, in order to build any observability framework, the prerequisite of is to have a proper logging framework to be built into the system. We cannot have something saying something is breaking like logger.info console.log, and that is just saying something has break. That will not serve you the purpose. You can have a very good AI system, but if you don't have observability system built in the system, you cannot get insights of it. That is where I am trying to emphasize on the part we should have a structured logging in our application. So that is the prerequisite to have a structured logging, and based on the structured logging, we will have a EMFs. So let me go to the next slide. So in any system that we're building, the logging is the most crucial part of it. And let's be frank, if you're having a log where we are just saying something break and just console.log something break, and we don't have any context of why it is break, when it break, which was the thing that triggered that break, then it's a cry for help. You cannot develop a observability framework if you don't have a proper structured logging. So what I'm proposing here is that let's use the tool that already AWS provides. AWS, we could use, if you use the serverless framework, we have Lambda Power Tools, which could easily integrate in the serverless framework. And using that, you could have a structured logging framework. You can define a log based upon your business requirement. You could categorize the log based upon the validations like error type and error code. And each log will have this sort of a beautiful JSON structure. So it becomes very easy for any system to understand why it is breaking and what has caused the break. And with this sort of a structure logging mechanism, we'll also have the end-to-end tracing. That is the most important. Which HTTP packet or which thing had triggered that failure, that is something that we should try to understand in end-to-end tracing. And having this structure logging will serve as a foundation for us to build a good observable system. So log should have a context, and that context should trigger a metric, and we need both to make a AI system. So this is the most important part, which I would like you to, in the complete session, give importance to. We cannot have a log without a context. That will not help us to debug. So each of our system should have a context in the logs, and that log should trigger a metric. If something is failing, that metric should be captured by CloudWatch alarms, and then we'll get to know why it is failing, why it is failing. And to build this thing in the serverless world, what I'm using is EMF. It's not something new. CloudWatch already has EMF. They call it embedded metric filter. So on each of the logs, if something fails, we have a hook that actually triggers an embedded metric filter, and we have a different sort of alarm based upon the different filters we have. Based upon any based on business application, we may have a validation error, payment error, database error, or dependency error, or any other error. So we are categorizing the error in your business domain language, and we can have different sort of errors, and using that we can have different alarms. So these are two main important things to build this framework: structured logging, and we should have a metric on each of the logs, so that we could, if something is breaking, or to capture that thing, we could hook it to an alarm. So this is the two main things. Okay. Okay, so this is the system architecture that we are trying to, that I will showcase in the demo part. So this mimics any traditional application that is currently live in production. Any application has this basic components always there. We have a front end that is attracted to some of the bunch of APIs. So we have API gateway to it. All the APIs may be interacting with compute resource. So here we have a Lambda function that mimics your compute resource part of your architecture. From there, the compute resources may be interacting to a database that might be doing a CRUD operations. So for database, I'm using DynamoDB. So this basically mimics your application layer in your production. The application productions are highly complex, but for the purpose of demo, I just have this sort of a three component that will suffice to say, okay, this is the applications. We have a API gateway front as a API handlers. We have a computer resource as Lambda, and some database for Dynamo. So any application production, if it's working fine, nothing breaks, we have a good day. Something breaks, we need to see why it is breaking. That is where we'll have a observability layer built on top of it. So let's say Lambda is a service compute that we're using, and we are logging it. As I mentioned before, we have a structured logs, we have a logging framework that logs everything. And if something is breaking in that in that flow, we'll be triggering an CloudWatch metric. We'll dispatching an EMF. That EMF will be captured by an alarm, and that alarm will s- trigger an workflow of step function. So, for example, if you are placing an order, let's say we have an order service that main job is to get input from the user and place an order. If something break in that flow, the Lambda will log that error, and it also shoot out an EMF. That EMF will be captured by our CloudWatch alarms, and it will hook out an alarm saying, hey, this alarm is raised. And that alarm, once it crosses a threshold, it will dispatch an event to EventBridge. That EventBridge will trigger a step function. This is the brain of our RCA pipeline. That step function now takes care to understand why something has break. Let's see and try to query the logs, so that we can give the production support team some analysis, because they are doing that manual stuff of searching the logs. Let's do that part. Let's do that step in some of the computers, so that will fetch the logs, send out an email, and then it will start the AI workflow. So this is what we're trying to build up here. So this is this three layers: application layer, observability layer, and RCA pipeline. This is something each system has it in bits and pieces. But if we try to orchestrate this thing in a neat fashion, then we'll have a completely a system that could scale to massive loads. If something is breaking, we can understand very clearly what's the reason for it to be break, and then how can debug it. So let me quickly go to the next slide. I will show you the RCA pipeline. Okay, so till now we discussed how the production system can log properly, and what, as an application manager team, what should we do to make sure we are able to understand the logs, and then we are able to understand the events that is triggering those error logs, and then we have to have some sort of workflow pipeline for it. So this is a very simple thing that we could build based upon, if you have the foundation correct, if you have the proper structure log present in your application, we can trigger an alarm. That is what the EMF does for you. It will trigger you an alarm for it, the CloudWatch alarms. Once that is done, we will have the workflow, step functions workflow, that will say based upon that alarm why it was failed. And based upon that, once we get to know why it is failing, we'll have the proper RCA to understand the reason. So what actually happens in the workflow is that based upon alarm, once the step function workflow triggers, it tries to query the log, proper log streams for that error message, because our logs have the contextual information present in it. The end-to-end traceability is there. So the workflow tries to get the error why it is failing, and once you get the match of that error, you shoot out the first email stating, hey, something is failing in production, maybe order is not getting placed. This is a log that you can use to understand. So it shortens your search window to exactly log stream where that has failed. So you can get the first part within seconds. Something has failed, this is the reason for it. And that will trigger a second workflow, we call it AI analysis workflow, that will use that log as an input and will feed to the AI engines and try to see what could be the possible RCA for that failure. Again, this part, the branch will be something, it's specific to your business domain, and it is something you could enhance. In this current demo, I put it very simple. I just simply use the context for the logs to trigger an Bedrock agent and then understand why something has failed. But in actuality, if you want to make this thing really robust, you could have a proper pipeline setup where you can use vector database to understand something has failed, and because you have to index your code and then could give you more insights for it. But that is where it's a decoupled, you could switch this branch to with your AI analysis system, and that you could scale this system, scale your application. So this basically serves as a basic workflow which you could enhance based upon your requirement. But the foundations are there. If you have the correct foundation present, if you scale this workflow, it will scale to your business needs. So that is where. And as I mentioned, even we have two branches. So if suppose the AI analysis is failing, you're not able to understand why something has failed, we still have the instant alert delivered to the user stating something has failed. This is the surrounding log that is saying why it has failed. And believe me, these things, having this analysis present and this event integration present, it saves a lot of time in a production critical system where each seconds count. And we are not playing Sherlock Holmes to understand why something is breaking in production. We have actual reason why something has break, and then we can proceed for it. So this is the workflow that we can have. And all this thing is completely built in AWS. It's not something we're paying something extra to get this information. We already have the system present, and we are using the tools that are there with some of the basic principles that we use, and we're able to build this thing. Okay. So this is the basic architecture. So what I'm trying to mimic here is the any production system, any traditional product system that has different dependency, different integrations, and how the system behaves. And then using this only, we'll try to demo a small piece that will see how this workflow can work. And that is where your creative hats will kick in, where you have to say, okay, this is the basic workflow. Now let's enhance it based upon our system, our production system, our different decoupled system, how could we enhance it? Because here we just have two Lambda function in production, we have thousands of Lambda function, multiple microservices are there, how the system can scale to that requirement. But the foundations, this system basically gives you a foundation how which you can use to build upon. So let's say in project system, for example, we have an APIs, bunch of API exposed to our backend system to interact with. So I'm using API gateway to mimic that part. And for the compute part, I have deployed a sample stack that has a serverless Lambda function that interact with DynamoDB, just mimic the CRUD operation part of it. And once that is done, it fetching it actually giving the logs to the CloudWatch, and it has integration with event bus as well, just to give any in any system we may interacting with DynamoDB, we may be interacting with event-driven system as well, maybe SQS or event based. So this box just basically says any example of any simple production system, and any failure that is happening, we are logging things to CloudWatch, and that is where we are using EMF to correctly quantify the metrics that we have, and that is actually triggering an workflow if then metric data is bypassed. Example, we have set a threshold of 2 errors per minute, we're getting 5 errors. based upon that email, if the alarm is triggered, that alarm actually triggers this workflow. And this workflow is the heart of our solution, where it tries to understand why something has failed based upon the alarm, get this information from the CloudWatch groups, trigger the initial RC email, and start the workflow for the AIRC email. And once the AIRC is done, we trigger an email stating, oh, this is has failed, this is the reason, and this is something you can look upon and debug on. So this complete thing saves your time and is able to do the complete end-to-end observability. Okay. Okay, so before I start, let me go through the like code and some demo as well, then we can go through it. So yeah, so if you see any real world scenario, we have logs present in the system, and this is something we get request id error code something, right? And with this foundation that we have built of the complete logging framework, we could have something delivered in the near real time fashion. Okay, so let me minimize it. We'll go through our code base, because what I want to do in the remaining part of the session to give a code walkthrough of this demo, and then we could start with the seeing the emails, how the workflow is running and all those stuff. So that will be okay. Second, so are you guys able to see this VS code? Because
Yes, it is visible, Saurabh, but if possible, you can increase slightly the font. Yeah.
font, okay.
Yeah.
Is it okay now?
Yes. Yes.
Yeah. So as we discussed, like we will try to mimic a production system, and we'll see how this workflow is able to scale to that system requirement. See, here we have a basic structure where we have a complete logging framework. We have bunch of resources. So if I go to infra, this is the workflow pipeline that we have deployed here. If I go to the ASL, yeah, second. Yeah. So this is the workflow that we have, the step function that we have present. So it's deployed here. So we have if I go to the code walkthrough of it, so this is the infra part contains our workflow that we have deployed, and I am using this sample lambda function to mimic the part where we can the API can interact with this compute resource, and it will mimic the part of calling our backend resources, maybe adding into a dynamic table, and if something is failing, it's trying to log everything. If you see this part, I have also added one logging framework. So this is the foundation that I was talking about. You can create one logging util as part of your coding practice, so that it's important, because observability should not be an afterthought, should be the first thought. So bake this thing as part of your code itself. And in debug and in to find things debugging serverless work is it's much more difficult as compared to containerized world. So have this logging util delivered, and you can, if you can see, I'm using lambda power tools for it, and using this I'm able to log everything. So we have a rule stating, okay, these are the default error types. This understand if something error is happening, this function will take care to dispatch an event. All those things happen. I will not go through the complete code walk. And these are something we can use to redact the PII, but this is something based upon your requirement you can build up. And using power tools gives you the end-to-end traceability, so you can have a request id to each of the logs. You can see the complete trace why this log failed and all this happened. So having this logging framework build up, this could scale to different services. We have a different microservices. You can still use the same logging framework, and that could take care to log correctly your details. So we will not have something like console.log. Having this library setter helps you. Okay. And yeah, this is it. This we have one lambda functions, one function that actually is used by step function to fetch your logs and understand why something is failing. And we have this step function, this definition added in the code itself, which get deployed. And for the deployment part, I'm using SST. SST is the wrapper which uses Pulumi to deploy things on AWS. So for the purposes of demo, I have prepared this sort of sample architecture so that we could see and able to understand the workflow is working or not if some failure is happening. So I will start it. And okay, so this is my AWS console. Let me grab the one demo app that I have built. We'll try to interact with the system that deployed, and we'll see if something is breaking. Are we able to see the workflow execution handling or not? And in the same part, we'll talk about the workflow execution, the logging practice that we follow, and this is how this thing helps to scale in the observability part. So this is one a basic simple page that I have created. So what it will do, the stack that we discussed, right? Simple backend stack that is interacting with the different resources. We'll try to invoke this endpoint and we'll try to see if something is happening or not. And I've built a chaos monkey into this integration, so it will fail sometime, it will pass sometime. And what we'll try to see if during failure part, are we getting the email RC or not? How the workflow is working. That is something we'll try to get it going. So let us try to place in order. So let me just try to update something. See, we got an error right now because the system is designed to fail at random times. So it fails sometime, it passes sometimes, and that is where we have to see during the failure part, are we able to get things or not. If I try to again this time it passed. So if you see each of the call is trying to mimic your production system, it is trying to call some of the bunch of the backend APIs and it's trying to place the order for you. Okay, so now let me give a big walkthrough as well. This is the Lambda function. We'll try to go to the table as well, just to make sure the system is live. We are sometime it is working, sometime it is not working. Yep. Yep. So if we are, so this time it failed. And now if I go to the CloudWatch, these are the alarms that I have. Yep. As you can see, some of the alarms are in, some of the alarms is in red state. That means something has failed. And if you see all this alarm that has been built up, it's built up from the framework that we have built. We have categorized the error in different categories. That category is sending out an EMF. That EMF is actually trigger different alarms, and we have a composite alarm that actually sum of all the alarms and triggers the workflow. So as you can see, 3 alarms are in trigger state now. And this, when these alarms are triggered, the integrations actually invoke the step functions. So if I go to step function, if I refresh it, so if you see some of the execution is already passed. And if we go to the working of one of the execution, bear in mind this the sample thing that I just showcased here, it's a sample app. It's basically fails sometime, passes sometime, because I have added randomness to failure sometime. Sometime it will randomly fail for no good reason. Okay. And this is the heart of it. So if you see, these are the different stages in the workflow. And again, this is something very basic, I would say, because this is something you could scale based upon a requirement. But the basic stages that is present is something any developer or any production SME does to debug anything in prod. So based upon the failure, the alarms are triggered because the alarms are looked to our application, and based upon the application framework, alarms get triggered, and based upon that, you can see different stages are there in the workflow. So first stage is a Lambda function that actually tries to fetch the logs based upon the alarm. So I will do a little more deep dive to show how this thing is built. If I go to fetch logs, The step function, this is the benefit of using workflow, a step function workflow, which I'm fan of. It's very easy to debug as well. If you can see, this is the input to this step function. It says, hey, this something has failed, this is the CloudWatch alarm state change, and something has failed, and this is the details of that alarm. This is triggered from this zone, this is the previous state, now this is an alarm, this is the configuration rule, and any order failure is detected. So this has triggered this, and this Lambda function now knows, based on this alarm context, which tool it needs to query for the logs. Currently it's querying the CloudWatch logs, but think about it. If we have a different observability tools like Dynatrace or logs or any system, this step could query from those systems as well. So when this is done, it starts a parallel execution where it first says you the initial email, because now the logs has already been fetched. So let's not wait the complete RCA to be done. Let's send out the first email stating, hey, something has failed. This may be the reason that has failed. See the logs for you to help in debugging. So this is the first part. Using SNS, we are sending out the first initial email, and then the second stages happen where it tries to understand the logs, parse the logs based upon the tool, and then it triggers an Bedrock RCA analysis pipeline where it calls the Amazon Nova AI model to get the analysis on the RCA. Now, here as well, the Amazon Nova model is something I used because it's relatively cheap, and with the for this purpose of POC, having cloud inscription, I was facing problem with billing, so I added the Bedrock, but it does the job. The idea is idea and motivation is same. You can initiate this step with and replace this step with different for your AI tool. You can have multiple models here, and that could be used, but for this RCA we can use this model. So once the Bedrock RCA is done, we send out the AI analysis email as well, stating why it has failed. Okay, so if you see, this is the RCA email, it has already sent out the email, and if I see the Bedrock RCA, it will try to say something why it was failed. So it's failing, saying DynamoDB, the Lambda function does not have an permission to put anything in DynamoDB. So this sort of a things, if happens in production, consider the load if you're getting so many things in prod, and if you're able to get this sort of an RC analysis, that is actually a lifesaver. So let me show you the emails as well. Okay. So we were doing the demo. If you can see, I have gotten 3 new notifications, right? So this is the email. This is the failure notification, the first part of the workflow where it says something has failed. And again, this is the very basic SNS integration. It's which you could scale to add a proper dashboard, use different services. You even use your organization email service provider to send out the email. But SNS for this purpose of demo does the job. It gives me the JSON format of something has failed, and I can also get the error. So as I mentioned, I have the chaos monkey built in. So for some random things, it fails. Now for this failure that happened when we are playing with our this HTML file, when I was doing this place order, sometime it failed. That time the randomness kicked in, and I can see the log stating, okay, this user, this Amazon, this Lambda service role does not have access to put item on this DynamoDB table. This was the error that I got, and this is something that is coming directly from the CloudWatch logs. And since we have built that foundation of how we should be logging everything based upon the Lambda power tools and the observability framework, I can easily get this error in the email. And now the second email that comes from RCA, because that first email serves as a context to our AI Bedrock agent. So it basically gives you this analysis. Hey, something has failed. This is the order failure that happened. This was the surrounding logs for it. This saying this invalid table name does not exist, and your Lambda function does not have permission. Now what as per the AI analysis says is that you can go and check the IAM permission role. Do you have access or not? If not, you can even give this permissions to this role. So it tries to give you the remediation steps as well. Again, it's up to the person handling this resource to understand what should be done. But we get this initial email that actually helps us to understand, okay, this has happened, this dynamic table does not exist, order request are failing into potential revenue loss, ensure that your IAM role, this is the Lambda service role that has necessary permission to put the item on this dynamic table. This is something based upon the failure that serves as the input, and we're able to get this from the Bedrock. So this sort of a things, if we are consider a production system, we are having this sort of outage, and having this emails does help to understand, okay, something is failed. We get the first one email of the actual application log stating something has failed, and then we can get the second thing from the RCA. So yeah, this is something that does saves the day. And we could, if built properly, if you configure the threshold properly, this thing can scale and you can able to get all the things. And bear in mind, this is something we have built, we're not using any additional third-party tools. It's something, it's completely on the AWS, and you can even deploy everything properly if you know what, how our application behaves and what you need to deploy. So this is the benefit of it, because I know there are different tools you can use, but using that tools do have additional cost and everything is there, but the foundation remains the same. You should have a proper structure logging for the system to work. And this is where, if you use this observability framework correctly with the AI in place, you can develop things. Yeah. So let's go back to this slide. Yeah. Yeah. So what we just witnessed was some what a mimic of the real world scenario where we were trying to place an order and it failed for some of the time. And then that was the raw log that was shipped to our system. And based upon that, we got the first initial email, and then AIRCA keep in where it says, okay, something has failed because order items was missing. And then what action can we do? What action can be done? Like in our case, based upon the randomness that I've added, I was referring to invalid table that was not present. Yeah, as you remember in the email, it was says invalid email, and that actually triggered the AI to say, make sure you have the necessary permission present. So those are things we get if you are able to capture those logs, trace those logs, and feed it to an AI engine. So this was the real scenario that we tested. We got an access denied on output item, and based upon that, we got the analysis from the AI. So this two part helps, because suppose there's a problem with AI, if you're not able to, AI can hallucinate and not get the actual RCA of it. The first email that you get, the initial RCA part, why something has failed, the surrounding logs of it, that actually will save you the day and not do the needed in the haystack problem. You can actually search very easily. Yeah. So right now, I built this sort of a histogram stating like the need of the hour is to have a centralized logging zero classification problem. So we should have a centralized logging framework. That is where I mentioned observability is difficult, and if you're trying to make observability in the decoupled serverless world where we have event-driven integration along with the serverless compute in place, it's very difficult to do end-to-end tracing. That is where you should have a centralized logging framework, and with the small POC that I showed, you can use this as a guiding principles to have this sort of a framework built in your application where you can have centralized logging, and that is used across your microservices. And then we have a custom alerts and malware investigation. So once you have a good logging framework, as you see, based upon the logging framework, we have a different alarms that was set up, right, based upon using EMF. Again, these things are not new. EMF is something that has been there for AWS for quite a long time, but if you use properly, the emap are easily able to trigger some of the alerts, and then we are able to get from that alert, we are able to fetch the actual failures and trigger an email to this team stating, okay, this has failed, this may be the reason that why it has failed. And if we cover this first part of it, centralized logging with the correct logging framework and custom alerts, we are covered for most of the cases. And if this thing is done correctly, then only we can have a RC agent in place. That is where we can have a second part of the thing implemented, where based upon our logging and our failures, we can have a proper RCS system built that can con different AI models, and even it can use your code context to understand why it has failed, and based upon that you can get the information. So we can have the RCA done, and then when the complete RCA is done, you can have a complete AI system. So this is the frameworks we can have. You can get crazy and have a different AI models added in the AIRC workflow system. You can have a separate workflow that actually handle it in a beautiful way. You can even index your code, put into a rack system that will help you understand why something has failed. So and this is something, if you start doing it, and I think our system will become more observable. And with the current tool that we already have in AWS, with little to no cost, we are able to do it. Yeah. So, and one more thing, in the last summit of AWS, we already have this DevOps agent delivered from AWS, and this DevOps agent. is also does the same thing that we are trying to show here, and that actually validates the thing that we're trying to build. Our solution is more streamlined to our business requirement, and if you're using AWS DevOps agent, it also has the inbuilt telemetry built in that actually try to correlate the end-to-end logs. And again, for correlating end-to-end logs, you cannot simply rely on services. You have to have a correct observability built in your system. That is where we have to have a use some proper library that gives you that part. And AWS Dev Agent does that part. You can get the end-to-end telemetry for it. You can do the triages as well, and you can trigger alarms based upon this. And this is what our workflow also built up. So this is where AWS, you can also look into how the AWS DevOps agent focuses on it, and it could be used. Yeah, yeah. Let's go to what next now. So if if you see, we based upon our integration, we went through the RCA pipeline properly, and we had the setup done, right? And this, let's be frank, this is very pretty simple setup that we have here, right? It's triggering some of the workflows based upon the understanding, right? And now right now what is doing, basically, to say very frankly, it's trying to understand why something has failed, capture those failures based upon the alarms, and trigger an AI workflow. Now, if you want to make this thing actually robust and make it more scalable, again, that is something this serves as a guiding principle. We can have a proper tries of other things stored in our some vector database. We can even index our code, and we could actually start saving this RCA. That would serve as a rack pipeline for us. We'll come to know, okay, something was failed 2 months back, some deployment might have happened. That may be the reason for this failure. This happened before. And since we have this RCA pipeline and we have this workflow setup in place, we could expand this setup to have multiple integration with different services, and that will can scale your requirement to different heights. So we have a vector database that could do different searches, and we can have historical RC also present. Using that, we could this could serve give more context to your AI agents, and that could give you the correlated RCS. Right now, things are independent. Something is breaking, we are getting this information, we are removing Bedrock, but the consider situation with this, even this AI pipeline can have context of your code as well, and you can understand why something has failed, what was the reason for this failure. It could go search your code and give you this information upfront. So those things are something that will happen that will be the next phase for this workflow. But that is something, if the team start using this and understand how this workflow is built, I think they could scale it, and that is what we're trying to showcase here. Yep. So yeah, three things that I want you guys to take away from this is that uh, monitoring observability cannot be an afterthought, and to build that up, you should have a structured logging in the foundation, and you should understand which are the logs that you want, categorize the logs, and that is what, if you have these things built, you can integrate with any system that you want to do, because that serves as your knowledge base, and thus serve as a context for the AI RC analysis. So you need to classify the errors in your app, because it's your application, you know which are the errors you have. Using this principle, if you classify the errors in the apps, the logs are not actually very vague, something like stating that something has failed. You know why actually the logs has failed, because each failure log is a currency that you can use to trigger an alarm that actually is getting used by the AI analysis RCA. So structured logging is the most important part of it. And yeah, as I also said before, we are using existing AWS services. It's not something that we are using variants. So we are using CloudWatch, EMF, Composite Alarm, EventBridge, Step Functions, Bedrock, and we are just wiring these things up in a custom homegrown solution that is serving better for us, and it's trying to mitigate the outages in the production. Yeah. And the very last part, you can start very small, try to classify the errors, have a proper analysis done of your system, and have the logging framework, because once you build the logging framework, things fall pretty neatly in the architecture, and you're able to go crazy with the different integration, have a different AI workflow added in your system. It can do multiple AI analysis for your failures. But the most important part is to capture those failures, because in production, it's not a matter of why it is failing, it's a matter of when it fails, what you do. So to actually answer the when part, you should have a structure logging present, and you have to be able to grasp all the things. So yeah, these are my three major takeaways of this demo. Yeah. And this is the tech stack that I used. Again, I will share the Git repository and the article that I have written. as a keynotes. You can go through this because um, I think once you get the hang of it, how things are there, I think this will can help you to understand. Yep. Yeah, I'm open for Q&A. Any questions we can do a deep dive on.
Hey, Saurabh. Yeah, thank you very much for that insightful session. So I see that you have deployed that UI application on CloudFront. If you have that open sourced or available on GitHub, it would be
Yeah,
great if you can share so that the users, I mean, not the CloudFront URL because I don't know, I don't want to share that publicly just in
yeah, yeah,
case
yeah,
thing
yeah.
happens. But if you have the code available on GitHub, or if you can push it to GitHub and share, that will be great. And I think within the same repository, if you can, yeah, you can include the blog post. I believe there are 2 or 3 part blog post.
Right, right, right. Yeah,
Right? So if you can add that, that would be great, and it can really help our audience to take it forward
yeah.
from where you have left. Yeah.
Sure, sure. I think I have it in the. I will share the blog post, Rashid. I think in that blog post I already added the information. So the Git
Perfect.
repositories are already public because my main motivation was to have some sort of a guiding principle where people can start, right? So you have a proper objective framework build up. Once that is done, then you can go crazy and have the RC analysis done. But the foundation part is important where you can use the already existing tools and get the things added. So yeah.
Absolutely, absolutely. So yeah, I mean, I'm also completely for building something in house, which is completely on
Yeah.
AWS instead of going a third party, especially coming from a startup, cost being the most important factor for us. So
Yeah.
we do have something built completely on CloudWatch in terms of monitoring and observability. But I think this takes one step forward with automatic analysis and RC and everything. So it is really cool, and I'm sure it is really helpful as well.
Yeah.
And yeah, thank you so much once again, Saurabh, for joining us today on a Saturday and sharing your knowledge. It was really helpful. I do not see any questions at this moment, but yeah, if anybody's interested, please reach out to Saurabh on LinkedIn. And yeah, thank you so much, Saurabh, and we're looking forward to having you again in the future.
Thank you, Shashit. Yeah.
Thank you. Thank you.
Thanks. Bye.
Okay. So yeah, I'm still having some challenges with my camera, so that's why it's I'm not able to come on camera. Okay, so now I think it's we can jump on to the next session, which will be by Pratik Raj, a senior developer at Serverless Guru. He will be talking about AI agents with Amazon Bedrock Agent Core. I mean, how can we have a session without AI agents in the picture, right? So, and we have Pratik joining us today. Hi, Pratik. Thank you for joining us today on a Saturday. You're on mute.
Yeah, hi. Thank you so much for having me.
Thank you, Pratik, for joining us. The stage is yours.
Yeah, sure. Let me know if my screen is visible.
Yes, it is visible.
Yeah. Hello, everyone. Thank you so much for this opportunity. So, starting with myself, I am Pratik Raj, and I'm currently working with Serverless Guru. Uh, we deep dive on the project. I'm currently working on a project to transform customer care services, and it's not just simple chatbot. We are building a full-fledged agentic system for the airline industries, and as everyone knows how chaotic it can be the customer service for any airlines. So we are trying to streamline that with heavy liftings behind the scenes with the agentic system so that it's very seamless for passengers. And big said that, that's intro for me. And that brings us to the topic for today and future of AI, like how we are shifting from just a simple chatbot to full-fledged acting agents, which can work on behalf of you. And here's the trap everyone falls into, and that's the building an agent is still beginners level, and there are lots of frameworks available on you, like you have LangChain, you have Llama Index, you have Strands. But the problem comes when you have to scale it to wide range of users spread across the globe, and that's where we have something which released last October only from AWS. That's called agent core from Bedrock, and that was bridges the gap between us. So building an agent and making it prod level. So starting into that, and so sure. So yeah, so starting with it, and as you know, like in recent years, AI has boomed a lot. In starting, it was just at core, it was next to kin generator, which was like you can converse with it, you can get access to informations which is it's been trained on. But that was kind of the limit. But with going forward, we also thought, okay, we can use it as a central brain for an agent to act, or even without human intervention, it can act on its own behind the scenes and streamline or like automate a lot of workflows, which is tedious for a human. You can say that. It can help you code, it can help you analyze your stocks, investments, savings, and whatnot. And that's what we are driving into. So, how the world is changing just from chatbots. Now we want the world to, as a user, I just don't want the information. I also want agent to act on my behalf. Like how are we doing things? It can be anything. It can write a documentation for you, create an email for you, send an email for on behalf of you. There are a lot of things which you can do. There are lots of use case on this, and that's what makes it fun. At core, we can use foundational model for all the informations we want. Basically, it's been trained on and it's going trained on a lot of informations, but it has its own limitations. That's where people build a lot of good frameworks, and you can build good agents in that with that frameworks. You know QI, LangChain, and Strands, etc. And that's how the world is moving forward. And that's like intelligence is shifting. So now we are not just asking the AI what it knows and what it can give us. We are also trying to take, please act on my behalf. And that's what closing the gap between, you can say, a proper AI how we had in our mind. We basically will make the AI work for us. That's a great thing. And with the core principle for that is agents. And we had to start with what is an agent. So agent you can consider as a brainless structure or a framework which acts like a messenger between different tools and the LLM. So agent doesn't decide something on its own, but it uses the LLM to give it full of instructions based on the what user is asking, and then it goes and fetches all those information from the tools which we laid out to it. And that's how it's like you can assume like a simple messenger which doesn't think on its own, but it knows where to go to get the information and it can follow instructions to the end. And that's what's great about agent. It's in many cases it can be stateless, you can add memory to it, and that's it. So there are three components to any agentic system. The first is the LLM, of course, and LLM is kind of the central brain to it. It will provide all the instructions, it will do the perception, it will get the context and provide you with set of instructions, which then agent as a messenger will go and fetch with all the functions and the tools which you have laid out. And the tools can be anything. It can be a web browser call, it can be an API call direct, or you can expose MCP tools these days. And all things the agent knows that if this is the instructions, this is the thing, I can go and fetch these data from here, then give it back to LLM, which then uses that live context to us. And that's kind of helpful also because, as you know, all the LLMs are trained on certain level. It has its limitation. Maybe it's trained 2 months back or 3 months back. So it doesn't have the latest information. And that's where the tools comes in, which it connects that trained LLM or AI to to the real world, what's happening today. And that's a great thing about it. And yeah, sure. So let me hold on. So what turns a foundational model into an agent? as I've explained like just now. So foundational models still has its limitation, and what it turns into an agent is we laid out tools which can be specific to a certain functions which we want to do. It's not like we laid out an infinite number of tools. It's a finite number of tools specific to certain instructions. And agents can loop through it. It can sense the context and try everything which it can to fetch all the relevant information and provide it to LLMs. So it's like it's a right hand or it's still like limbs to the LLM, which like it can go and fetch data for it. And that's what makes a simple foundation model as an into a fully agentic system. And let's start with the agentic architecture, of course. So an agent system is built on some reasoning. So user asks something, user has a query, it can be a prompt, it asks that I need so and so thing. Then it has to be perceived by the LLM that, okay, this user is asking something. So for that, I need this set of instructions, which I can ask the agent to fetch. And it thinks on its own, okay, these are the things I need. So that goes with the reasoning. It goes to the agentic system and the framework, and it asks, okay, it knows that these are the tools which I can use to get these informations, and it sets instructions based on that. And it can happen, it's not just like it's one-off thing. It can happen on action loops. Agent goes, okay, I fetched some data, and then again I came thinking like, okay, this data is okay, but I need some more information to actually response to the user. That's where it happens. It can do a web search. It can even generate a code and run it on the go. Let's say there is some data analysis or something, and that's the major part of it. And one of the main now coming to the main key part, which I think is very important to any agentic system, is the memory. Because without memory, an agent is just like you ask something and it returns the response, but it doesn't remember what conversation you had. Now, sometimes this thing is very important because you want to give a personalized experience to every user as a service. And this is how it works. You have to provide a full memory. And once again, sorry. Yeah. So the memory is like two, memory can be divided into two factions. One is, of course, the short-term context and the long-term context. The short-term is the line to line what we had in a given session. So I started a session with an agentic system. I work on it, and it's basically like it knows exact what each line what it did. Agent has the idea that okay, for this query I had answered this already, and I have this information. So this is short term and it's very beneficial for a chat session because you don't want to lose the context. If user is asking something and then it asks something else, you have to correlate between the two. And then comes the long-term storage. So long-term storage it's not feasible to store it as how do you say line by line or like each detail. So long-term storage is more of a context storing where we store it as full context of what had chat. So the it's like the memory has some information of the user but not all, and it creates a perception on that part. It's like this user has asked so and so questions in the previous and it's related to these things, so we can use that and answer. And you can use any nowadays cloud or Gemini apps and all remember about you, like even remember what you talked 1 month, and it can use it to give a better personalized response for you. So that's why any agentic system memory is kind of, I think, a key portion of it. And of course then there is tools. I mean, without tools there is no agentic system. You have the tools like you have APIs, search, and code executions. So tools can be anything. It can be a simple function which adds two numbers. It can be a full-fledged API system hosted somewhere. It can be a browser search or a Google search. And it can also be a code execution where the agent just generates a code and run it on certain sets of inputs on the go. So it can better analyze things. But there is always is some problem. Like you cannot have infinite number of tools laid out to an agent. It leads to a lot of issues, and as you know, LLMs hallucinates a lot, so it can go to a wrong tools. It can keep on trying on the wrong tools and just burn the tokens and never reach anywhere. That's where multi-agent architecture comes in, where instead of calling tools, the orchestrator just doesn't call the tools. It calls different agents designed for different specific purposes. In that way, we are just breaking the problem into smaller parts, and each agent is like focusing on its own domain and not domain. And that's good because then you can have infinite number. You can have just finite set of tools which each agent can focus. And that's about agentic architecture. Now, how does agent core comes into the picture? Because as I told you, like building a agent is one thing, but building an agent on a production level, which is uh, scalable, which is available to across all cloud, what like big enterprises do that, right? And this is where agent core comes. So what is agent core? Agent core was released last October, I think, 2025, um, by AWS to bridge this exact gap, where you can have a platform where you can host your agentic systems, you can deploy, you can scale it up, you can connect it to an API endpoint to expose it to the other users and whatnot. And that's the best part of it. It provides you a very seamless and meticulous platform where you can deploy agents, and it's more like the architecture is more like a serverless architecture, so you pay as you go. It's not a continuously running, but it's more of a service where like it's Lambda, like we just pay for what's being invoked, and that's what Agent Core handles very good. It can be, it has auto load balancers, it can auto scale based on whatever you configure, and it can be available globally. And you can have multi regions collaborations on this, and it will work as charm. What separates is like it's under the AWS. So of course it's secure. You have the IAM permissions. You have full control on who can access these things. You have the full network security layers. You can go it. You can have it under a VPC, as many enterprises do that. And I've already explained that it's a serverless execution environment, so you pay as you go. And then you have status chatter persistent experience, because Agent Core provides you the full architected memory system out of the box. You do not have to worry about those. You just plug in those credentials, so memory plug, and it works fine. And that's one good thing about it. It provides other things also as out of the box, which I'll cover in the next slides. And one good thing is, since it's AWS, you can standardize your API communication. You can connect to API gateway. You can have it as a full network systems, and it you can have it across different regions, and it'll work. Okay, so that's okay, let's move on to next, and that's the core features. One of the uh, main core features of agent core I like is the session isolation. So each invocation works as its own containerized thing. There is no data sharing, so it's like one session has its own isolated execution. You manage the memory, and the management of any code is very good in that part. And the runtime is almost always available. You can scale it up and down as you wish. And as explained, we have the memory and the context management. And I have tried with Agent Core. The memory management is so good. It's really fast. It also provides you direct connections to knowledge graphs inbuilt. So you can store lots of long-term data for a given user, even Even you can store in the informations or data which is related to just the enterprise, which is not available publicly on the internet. So those things you can store and you can attach it to the memory and the context management, which then it can use. We as a developer, we are using it a lot in our customer services because there are a few things which airlines manage internally, and that's where memory and context management comes in. And then you have identity and access control, which is again the IAM. You have the full control who can access to those memories, who can invoke those, and you have full-fledged control which AWS provides you. It directly connects to API gateway, so it's an exposable API, and you do not have to worry because AWS handles all this infrastructure behind the scenes. All you need to worry about is writing the code for the agents, building and architecting it. And of course, with AWS, we always want the logs, the observability of it, because as you know, agents and bugs is sometimes it can stuck in a loop. It can hallucinate. It can go in a wrong direction, and that's where observability on any logs will come in a very handy because every logs in agent core shows exact thinking of the LLM at each steps, what it is doing, what it is trying to do next, and that's where you can control, you can tweak it as per your requirement. And this is the agent core architecture. And if you see it, we have different kind of layers. We have app layer, we have model layer, we have runtime layer, memory layer, and the expose execution gateway layer. Starting with the multi-agent or multi-model, you can build both. You can build a multi-agent or you can build a single agent. It supports both. And then runtime layer is the part where you host your agents. And it comes with a lot of out-of-the-box tools on its own. Like what the major ones are the browser and the code interpreter, where it gives you an inbuilt feature to go search the web as it requires. It can go and search the web for the latest information. It can generate and run and execute code on the go as it requires. And these are all are provided in the runtime only. It's out of the box. Prompt management is also there. You can have internal prompt management for it. You can configure a number of tools depending on what's the requirement of any agent. You have the knowledge graphs for any context management, which is directly connected to the runtime layers. And of course, you have full identity and policy. You can use Cognito. You can use other layers for security. And that's how the architecture is. Then we have the memory layer, which is, again, I say is one of the key layers for any agentic system. And memory layer is kind of built separately depending on how you build it. You can have the internal short-term memories, you can have the long-term knowledge graphs connected to it, and it gets built on that. Let's go to the next. So how the data flows agent go. And this is something interesting because as till now you have not known like how agent works. It goes from user asks the prompt, it goes to the runtime, then the runtime layer will probably go to LLMs for the brain. And it will ask, okay, these are the instructions, what should I do? Naturally, LLM will come up with a set of instructions for the first layer. It will go and fetch those information from the relevant tools. Or if it needs it can search from the memory and whatnot. And that's a good thing because the LLM and the runtime are kind of isolated. So it's like there is a to and fro, but both lies in a different arena, and that what makes it kind of secure. It you can set up all your guardrails and limitations and what the LLM and the agent can do based on the instructions without worrying about tweaking the LLM for it. And based on that, it goes and fetches all the context, which again it can run in a loop till it is confident enough that yeah, it has answered the user query. and it can go to the browser, it can use a code interpreter, it can analyze things and go response with whatever actionable outputs and the securities are there. And then we have the runtime, which is the main platform where our agent lies. One good core features about it is like purely secure execution. It has isolated sessions, as I've explained, and then you have long run times. By default, it is set for, I think, 60 seconds, but it can go as up as 8 hours. You can have agents running for continuously 8 hours. I mean, of course, that will cause a lot of token burn, but you can have any big enterprise can have long running migrations, which is happening, and they can be done via agents, which requires a long time. So it can in the background work a long time and without worrying about session ending. Each session can go. And then you have private network support because any big enterprise will always fetch data, but it tries to be inside virtual networks. Even the one I'm working on is a completely another VPC, and that's good because you do not want the internal data to go out in the public internet. So that's how we keep the gateway. All the agentic runs are happening inside a private secure network. Okay, so now we have one key feature which we should actually think on is the memory. As I've explained, like so memory can be different short terms and long term. Short terms are actually very good if you want to keep the session inside. I mean, give an example. Let's say if a user asks something and it gets a response, but it's not uh, the user is not too happy with it or too satisfied with it. So it might go and okay, I want it in this way. But what will happen is without the short-term memory, it's more like a new request. It's like agent doesn't know you at all, what you asked before. And agent will be like, okay, this is a new request. I will plan it and I'll work on it as something new, which can be of irritating for any user because not every prompt you want to give all the details again and again. And that's where short-term memory is a very useful thing. It goes in line by line memory and it knows exactly what the response was before, what was asked before, and it can use in its own context to plan accordingly. It's like self-learning from the memory. Now there comes the long-term contextual memory, which is good for a personalization experience. Like let's say you have been a user for with a for a product or for a company for a long time. So you want to know, like you want to keep that, okay, this system knows me. It knows what I have asked before. It knows what are my requirements, and that's where it's very helpful. Like any agentic system, long-term memory is helpful because it knows that particular user and what it needs, and it can use it to better personalize the response. And that's why agent core is very good because the memory management is fully serverless and it's also scalable based on the user requirement. And let's move on to the next one. And then we have agent code browser. So why is browser required and why is browser needed at all? As you know, LLMs are not trained continuously. It's trained and it's released, and then they try to train it after certain intervals. But what will happen if there is some news or some case or some new information came yesterday? It will never know about it. But your agentic system cannot afford that. You have to know what happens. Like let's say for an airline example, any customer will try to know, okay, why my flight was delayed. There should be a reason, and that data keeps on updated on the backend. So that's where it can either go with the public data, it can go for the weather informations, it can go fetch different kind of news or different kind of informations from the browser, or it can go internet also. But for any agent, many agent will try to fetch data from live internet. It's basically like how we Google things and we get information, and that's how Agent Core will do. And that's the good thing because Agent Core provides the browser out of the box. It handles everything internally, and you do not have to even specify the tools. It automatically attaches the browser tool with your agent whenever you deploy, and it gives you full access to the live internet without interruptions, without bot issues. It even handles the captchas for you, and in many cases, it can download the full HTML layout of it to figure out the data. And it's purely serverless and scalable at runtime. And all these web tasks is not just a simple Google search. It can go into iterations where it can visit different sites before reaching a conclusions. It's not like it will just make a Google search. It will go to different site in the different varieties and try to gather all the information it can. And then there is code interpreter. Code interpreters is kind of good because you want not all the informations are available on the internet, or you might not have thought on each tool's code. There are let's say for you are trying to analysis on stock or some big financial data. You cannot write a code beforehand for that. You cannot create a tool for that beforehand. What needs to be done is you have to have a code interpreter where based on the data structure, the agent or the LLM can generate a code which then it needs a place where it can run it with the provided input. So it can provide a final analysis, which again then agents can use for further steps. And that's what agent code does. It provides you a out of the box interpreter for it. And it's again completely serverless and it's isolated executions and it kind of supports almost all the languages till all the famous languages. I think I know it supports Java, Python, and whatnot. It has a full-fledged environment container, so it can install all the required libraries and what. And in the isolated executions, it's like short-lived executions, and it provides a full ability to generate and in many cases there is an option to even retain those codes. So let's say if an agent thinks, okay, this code which I generated can be reused again, it can live in the code interpreter as a image and you can use it again and again. That's one of the good features of it. And then coming to the MCP tools. So everyone knows about MCP tools and it's kind of very famous in these days. Where it has standardized each tools how we expose a tool to any given system. So almost all big enterprises like Adobe or Atlassian and everyone have released MCPs for its Jira tickets or maybe a conference page, whatnot. And that's one great thing. You can also create a custom MCP tools with simple Lambda. You can convert a simple Lambdas into MCP tools of your choice. And you can use everything in the agent code. Agent code can have all these features to directly connect to already built MCP tools, or it helps you create a custom MCP tools, which you can convert anytime. It has a centralized governance and each part is observable at each time. So which tool has been called, which MCP tool returned what is always logged. So you know at each steps what's happening. And then moving to the monitoring, which is again, as from the last session, you might have thought like, okay, monitoring is one of the most important things of any system because without knowing what is happening and what could possibly break or even what is breaking currently, we cannot move forward. And this is what Agent Post excels at is it provides a full access to the CloudWatch logs. Each and every executions and each and every invocations always by default goes into the CloudWatch logs. You have full traces, metrics, and you can even configure your own oral integrations if you want some specific custom metrics and alarms set on some invocations, and everything is well. Because when it comes to agent, there are a lot of things which can go out of hand. There is no human always monitoring what the request is coming and what the agent is thinking always. It's running in the background of the loop. So you need all these monitoring tools, of course, to handle whatever things can may go wrong or is going wrong. And that's the beauty of it. Uh, Now coming to the enterprise concerns which we faced as and when we were starting working. And this first thing is always in recent times, everyone have heard like how many security breaches are happening these days. Every now and then you hear, okay, this open source package has been checked or some security breach happened and some data information is gone. And that's where the concerns are valid for any enterprises. We have the security concerns, you have the guardrails. We want to define what agents has the boundaries. Otherwise, agents can go in any directions. We want some humans in the loop, of course, to make hard decisions or at least monitor something because you don't want the agent to run on its own always. And all things have been provided by agent code. It has security features. You can, as mentioned earlier, you can host it inside of private networks. You can limit its accessibility using IAM rules and permissions. The guardrails of Bedrock is already known for being strict, where it can handle a lot of things and limit agent to what it specifically needs to do without straying away from the core principles. Then we also have a feature where we can configure things to make to send an alert via mail or SNS topics where it can push notifications and alerts to a human based on if it thinks, okay, these things are going long runs or it's breaking the chain. So these things, and then in the human, it can ask for the loops. And after that, agent code will build on that. And that's what autonomy brings a challenge. Who will be accountable? That's why the human in the loop is one of the good features agent code provides. And at last, like there are lots of frameworks, so QA, LangChain, Lambda, and Strands, and which one to use. So Agent Core is mostly vendor agnostic in this case because it kind of allows you to deploy agents with build with any of the frameworks. But one good thing is AWS also came up with its own framework. It's called Strands Agents, and it's a very good lightweight framework for building multi-agents, and it's kind of, I think, leader in the multi-agents autonomous types. Many we kind of use Strands because it's from AWS. It's, you can say, it's kind of optimized for agent code. It's lightweight, so deployment is not a issue for us, and it supports direct MCP connections to almost. Um, it's kind of generalized, so it's almost every MCP connections is built for it. Strands out of the box doesn't handle the memory, and it uses agent code's memory management for its executions and the runtimes. This is it, and this is where this was all about the features and agent core. And I try to build a small, very small demo on what's possible with agents. And before I start in that, there is one more thing. Agent core's one good feature is you can run the agents or testings either locally or after deployment, and you just have to provide with your AWS credentials and everything works locals too without the deployment. And then you, when you're confident enough, you can deploy to the agent core for all systems. And this is one of the small demo I was trying where we are on a side, we are trying to build a product or like agent system which can formulate different costings of and cost offerings from different companies, and it can fetch out like, okay, compare it with let's say a particular enterprise's cost, or let's say in our enterprise only, and compares and drafts a whole email for it, where it can provide potential customers on how a enterprise or any company can be beneficial compared to so and so. And this is the whole architecture for it. It's a very simple demo, and this is how the we'll go to the demo and soon. And with this the designing, let me try the demo for you. So yeah, this is the demo part where, yeah, I forgot to mention one thing, and it's like one good thing about Agent Core is you're not just limited with models provided by the Bedrock. You can use Google Gemini, which even is third party from AWS perspective, and you can use anyone as long as you provide the key, and it kind of works with everything. So it's kind of a vendor agnostic in that sense, which is kind of good. And let me show you just how it's like. So let's say I tried with this prompt. You can try any prompt here, but yeah, let's start with this. And you can see it's showing you each and every thoughts as and when it's going. It can make multiple iterations through different websites using the browser tool of the agent core to give you full all-around informations before reaching any conclusion. This is taking a little more time. You see it has found, and yeah, so I'm not sure if it's visible, but you can see it has searched for, and it found the price for each rent per month and compared to ours, which in my case is just in hard coded data because I do not have own a company. And this is like, and it will also send an email. I'm not sure if that function is still working or not. So with that, you're trying to, yeah, so that's pretty much, you can do a lot of things with agent core, and you can think of different scenarios. You can use the different inbuilt tools without worrying about the infrastructure at all. And that's one beauty of agent core. That's okay. We are ending with that. Any questions on this?
Thank you so much, Prateek, for this wonderful session. I'm also getting started with Agent Core, and as you already covered, there's so many tools options available, and given that you can use any framework and deploy it on Agent Core is I think really helpful, because almost always people get started with agents, but then it starts working locally. The next immediate question is, where do I deploy, and
Yes.
how do I make sure it is scalable, I can observe it and monitor it and everything. And I think Agent Core is the answer for all of that. I do not see any questions at this point, and I think you've already shared the QR code for the GitHub repository, so that is great. So yeah, thank you so much, Prateek, for joining us today and sharing your knowledge with our audience. It was really great having you here, and we're looking forward to having you again in the future.
Sure. Thank you so much for the opportunity.
Thank you so much. So yeah, that is pretty much it from our side for this month of Serverless Saturdays. I hope you all had a couple of insightful sessions and you take something out of it, and you still have 1.5 day over the weekend, and probably go build something yourself. So yeah, with that, we're coming to an end. If someone is interested in presenting at Serverless Saturdays, please do reach out to me on LinkedIn or Twitter or wherever you want, and we'll be more than happy to host you at our event. So thank you so much, everybody, for joining, and uh, see you next time. Thank you.